Okay, so today we're starting chapter 3. And chapter 3 is all about parallel lines and different angle pairs formed by parallel lines and transversals, or just standard two lines of transversals. So we'll talk about what a transversal is in a minute. It's on this vocabulary sheet. So the first thing we're going to talk about are parallel lines. So remember from Algebra 1, and probably from other middle school math classes, that parallel lines are lines that never intersect. And then just as a general note, parallel lines must be coplanar. So they have to be on the same plane in order to be parallel as well. So, for example, let's say I have line A, and I have line B, and I want to say that they're parallel to each other. So A is parallel to B. Remember, I'm using a cursive lowercase b because I'm naming a line by a lowercase script letter. Remember that, or just in case you didn't know, this symbol right here, these two straight vertical lines, so they're kind of a little bit longer than the text that we're writing on either side, is the symbol for parallel. Okay. Now, when we look at pictures, we also can note that something is parallel. So, what we need to do that is we mark it with these little arrows in like the middle. Usually they're filled in. And if they have the same number of arrows on that line, then they're going to be parallel to each other. So right now I have one set of arrows on each in the middle of that segment. And so I know that line A is parallel to line B because of these little arrows in the middle. Now, if you have many lines that are parallel to each other, you might need more than one way to mark that those lines are parallel. So you just increase the number of little filled-in arrows in the middle of the line. So for example, I just made it so there's two little arrows in the middle, so that still says that line A is parallel to line B. Similarly, we also need to talk about perpendicular lines. Now, perpendicular lines do not need to be coplanar. They can be coming from different planes and intersecting. They could be coplanar, where they're on the same plane and they intersect at a 90-degree angle. That's all that they are. Perpendicular lines are lines that intersect at a right angle. So, for example, if I have line C and line D, so C is perpendicular to D. So this symbol for perpendicular looks like an upside down T. So if you want to say two lines were perpendicular to each other, you say line C. We should have the word line in front of it, but we kind of just shorthanded in this chapter to just a lowercase c. And then we use this perpendicular symbol, and then we put the other line at the end. Now, on our pictures, to know that they're perpendicular, they have to either A, say that the angle is 90 degrees, or B, it needs to have that right angle symbol, that little box. So either A needs to have a box, or B, it needs to say that it's 90 degrees. You cannot assume that something is a right angle unless it tells you. So if it tells you by the angle measure is 90, or it tells you by the little box saying that there is a right angle as well, or if there's a statement saying that the lines are perpendicular to each other, then you can use that. Okay, so the next one is called skew lines. Now, skew lines have a few different things that we need to keep in mind. The first thing we need to know about skew lines, they are lines that are non-coplanar. So if they are not coplanar, that means they are not on the same plane. The second thing we know about them is that they are not parallel. Which, if they're not coplanar, then they can't be parallel, because in order to be parallel, they have to be on the same plane. Which we talked about that when we talked about parallel lines. And then the last thing that you know about them is that they do not intersect. So what I'm going to do is I'm going to choose one of these sides to represent my line. So we have a three-dimensional cube. I'm going to use this segment back here. I'm going to call it line S. Now, the first thing we're going to do with this line S is we're going to try to figure out which places we cannot put one. So, for example, I want to say, okay, our other line that we're going to draw has to be non-coplanar. So I'm going to figure out what all of the coplanar segments would be with line S so that I know I can't use those. So S is part of the top plane of this cube. So that means that this segment, and this segment are all coplanar with line S. So I cannot choose those segments as my skew line. Now, S is also a part of that left side of the cube that we can't quite see. So this segment, and this segment are also coplanar with line S. So I cannot use those segments. And then lastly, remember we can still have a diagonal plane here. So that means this segment on that front right edge, that edge right there, that's also coplanar with line S. So I can't use that. Okay, now that we've done all that fun stuff and marked those off, we only have 4 segments left. I'm going to take a second and highlight those. Actually, I'm going to use blue. So this segment right here is not coplanar with line S. The segment in the back is non-coplanar with line S. And these 2 front vertical pieces are also non-coplanar with line S. So any 4 of those segments could be our skew line with line S. So I'm going to choose this one that's on the front edge right here. I'm going to call it line T. So line S and line T are skew lines. Now remember, you could have chosen any of the other 3 blue highlighted segments as well. So if I called one of them like U, one of them B, one of them W, I could say that S is skewed to line T, line P, line U, and line W. All 4 of those are skewed lines to line S. Okay, so similar to parallel lines, we also have parallel planes. So parallel planes are planes that do not intersect, or planes that never intersect. So if I look at my cube, I'm going to call the plane on the top of the cube plane R, and the plane on the bottom of the cube plane S. And then I'm going to take a highlighter and I'm going to highlight those planes. So you'll notice that plane R and plane S are not going to intersect because they've got those cubes, or at those opposite sides of the cube, to be parallel to each other. So we would say that plane R and plane Q are parallel planes. Plane R and plane S. Remember, you need planes by capital print letters or by 3 points on the plane. Since I decided to call them plane R or plane X, we named them by that capital print letter. Okay, so the last thing we need to talk about before we talk about all these theorems are what is called a transversal. So a transversal is a line that intersects two or more lines at different points. So for example, I'm going to have line A. I'm going to have line B. So right now, line A is intersecting line B, and line B is intersecting line A. Now I only have 2 lines, so I can't use that yet. But let's say I have a third line, line C, that's going to intersect both line A and line B at different points. And so that would make line C the transversal of line A and line B. Or I also noticed that line A intersects line C and line B. So line A is a transversal when it intersects line C and line B. And then additionally, line B intersects line A and line C. So it's also transversal. So just in general, transversal is a line that intersects 2 or more lines at different points. So typically though, we're going to have something that looks more like these pictures on the right. So the first thing we have are called corresponding angles. Corresponding angles are angles on the same side of the transversal and the same side of the other 2 lines. So they have to be on the same side of the transversal. So in this case, our transversal is this line right here. I'm going to call it T for transversal. Now, in order for them to be corresponding, they need to have be on the same side of the transversal. So I'm going to choose just one of the angles on the left side of the transversal. I'm going to choose angle 1. So angle 1 is to the left of the transversal, and it is above that line that it's connected to. I'm going to have something to call it. I'm going to call this line A and this line B. So angle 1 is to the left of the transversal T, and it is above line A. So now I'm going to go down to the bottom set of angles, 5, 6, 7, 8. So I need an angle that is to the left of transversal T and is above line B. Well, that would be angle 5. So angle 1 and angle 5 are corresponding angles. Okay, let's choose another one. So I'm going to choose angle 6. So angle 6 is to the right of the transversal and is above line B. So now I go up to the other 4 angles, 1, 2, 3, and 4. I need an angle to the right of the transversal and above line A. So that would be angle 2. So angle 2 and angle 6 are corresponding angles. My next set of corresponding angles would be angle 3 and angle 7. They are both to the left of the transversal, and they are below their respective line. And then, I'm sure you guys have guessed it, our last pair of corresponding angles are angle 4 and angle 8. They are both to the right of the transversal and below their respective line. Now, if the lines are parallel, so if line A was parallel to line B, then we would know that all of those corresponding angles are congruent. So we would know angle 1 is congruent to angle 5 if the lines are parallel. Angle 2 is congruent to angle 6 if the lines are parallel. Angle 3 is congruent to angle 7 if the lines are parallel. And angle 4 is congruent to angle 8 if the lines are parallel. So that's the corresponding angles theorem. So if the lines are parallel, we're using the corresponding angles theorem. If we're just identifying corresponding angles, we're using that definition. Okay. So the next angle pair we're going to talk about are called alternate interior angles. So alternate interior angles are angles on opposite sides of the transversal. That's why they're called alternate, okay? They are called alternate interior angles because they are on opposite sides of the transversal, so alternate sides. And they are inside the two lines. Now, if the lines are parallel, then we know that alternate interior angles are also congruent. So, first thing we're going to do is identify some alternate interior angles. So, they need to be inside the two lines. So, inside, so angles that are inside the two lines would be angle 3, 4, 5, and 6. We'll talk about 1, 2, 7, 8 in a second on the next page when we talk about alternate exterior angles. So I'm going to choose an angle that's on the interior, so angle 3. It is on the left side of the transversal, so its alternate interior angle must be to the right side of the transversal, and it needs to be in the other set of 4 angles. So angle 4, although it's inside and it's on the opposite side of the transversal as angle 3, it's in the same angle set, like in the same chunk as angle 3. So I can't choose angle 4. I have to choose either angle 5 or angle 6 because I need your angle pairs. There's always one from the top set of angles and one from the bottom set of angles. So that means I'm going to have angle 3 and angle 6. So angle 3 and angle 6 are alternate interior angles. They are on opposite sides of the transversal and they are inside the two lines. Our other set of alternate interior angles are angle 4 and angle 5. So if I was to talk about their congruence, I would say angle 3 is congruent to angle 6. And angle 4 is congruent to angle 5. But that's only if those two lines that we're using are parallel to each other. If they're not, we can just say that they're alternate interior angles, but we cannot talk about their measure unless the lines are parallel. Okay. So if between the two lines is the interior, then what is outside of those two lines is considered the exterior. So this part is the interior. So the exterior angles are angle 1, angle 2, angle 7, and angle 8. because they are outside of the two lines. So alternate exterior angles are angles on opposite sides of the transversal. And they are outside the two lines. Now, similarly to alternate interior angles, if the lines are parallel, then alternate exterior angles are congruent. So I need to choose an angle that's in the exterior, so I'm going to choose angle 1. And so I need an angle on the other side of the transversal, is in the exterior, and is in the other group of numbers. So that would be angle 8. It's on the right side of the transversal, and it's in the exterior, and it's from the opposite group of numbers. Okay? So now, if I choose angle 7, angle 7 is in the bottom set of angles. So I need an angle from the top set, and I need one on the right side of the transversal. So that would be angle 2. So if I was talking about their congruence, if the lines are parallel, I would know that angle 1 is congruent to angle 8, and angle 7 will be congruent to angle 2. Again, you can only say they are congruent if the lines are parallel. Otherwise, we can just identify that they are alternate exterior angles, and that's it. So our last angle theorem for today is the consecutive interior angles theorem. Some textbooks or resources online also call these same side interior angles. So if you're like ever looking at some YouTube videos or whatnot, trying to review this content, and you hear or see something about same side interior angles, that's the same thing as consecutive interior angles. They're just, it's just a different name for it. So consecutive interior angles are angles on the same side of the transversal. And they say interior, so they're going to be inside the two lines. So now if the lines are parallel, then the consecutive interior angles will be supplementary. So this is the only angle pair from this chapter that we'll talk about where they add to 180 degrees. Everything else is congruent. So they need to be in the interior, so they have to be between these two lines. They need to be on the same side of the transversal. So they're going to be like right next to each other. So angle 3 and angle 5 are consecutive interior angles, and angle 4 and angle 6. So I would say that the measure of angle 3 plus the measure of angle 5 equals 180 degrees if the lines are parallel, or that the measure of angle 4 plus the measure of angle 6 equals 180 degrees if the lines are parallel. Okay, so those are your vocabulary parts of your notes. So now what we're going to do is we're going to go do the notes part of the notes.